Hello everyone. I am Abhishek Byanjankar and today I'm going to present a presentation on topic like I have to solve a matrix problem, so I gave a title as matrix solved in Python. So as we go ahead, you can see that can matrix question be solved through programming? So to answer this, I would like to take you back. Like, I asked this question. I asked the same question. Like I asked, can maths question be solved through programming to my brother, and he said that everything you see is math. And I was like, how? Can you please explain to me how computer is a math? And he just said 0 and 1, and I understood. So the answer is yes, we can. So here we go. So moving ahead, you can see the question that had been provided by faculty Mr. Durga Thakal sir. So the question says encode the message happy life by using the matrix -4, 5, 1, -1, which is 2 into 2 matrix. The ascending alphabet order starts from 1 continuously. So this is the question that had been given by faculty. So and I solved it in the paper. So this I would just explain it in short because I will do the same question in my programming in Python. So what I did is I turned this h into 8 in a ASCII number. So I turned this h as 8, a as 1, p as 16. So now I took this into a matrix form, 2 into 5 matrix. So after that, I multiplied the matrix, message matrix with the matrix given in the question. After multiplying, it gives, it is the encoded the message has been encoded. So you might have a question in your mind. Why did I did 2 into 5 matrix over here? So because 2 into 5 and the question over here is 2 into 2 matrix, so 2 into 2 into 2 matrix and 2 into 5 matrix, I have to the matrix which is 2, which first row and is first column and second this column and this this first column and first row should be same, otherwise it can be multiplied, if not then it won't be multiplied. So as you can see, 2 into 2 matrix over here and 2 into 5 matrix, so 2 is same, so we can multiply it. So the question has been encoded. After that, I was curious. I encoded the message, so how should I decode this? And I just brainstormed it and I wrote it in paper. Like I did rough like around 5 times and I got an idea. So for decoding we have to do a inverse like this. If we do a inverse, then the equation -4 5 1 -1 would be 1 5 1 4. So after that I multiplied with the encoded message. The a inverse is multiplied with the encoded message. After that, the code is decoded. So you can see 8 1 16 16 25 0 12 9 6 5 8 1 16 16. The message that we just made a ASAC key number had been same over here. So it means like RHS is equal to LHS proved. So the encoded message is decoded by inverse multiplication. So hence the encoded message is happy life. the encoded matrix minus 27 7 16 0 minus 100 25 minus 3 3 1 1. To check the encoded message is correct or not, I have decoded over here. So you might have in your mind like, where is this implemented? Is this implemented in real life? So I did bit research about it, and encoding and decoding messages used to be very highly confidential messages. For instance, during Second World War, Germany used to encode and decode messages to drop missiles, bombs, etc. in the enemy's territory. So this is the one of the best example for this. And in this modern world, the computers like end-to-end encryption is also one of the example of this. It is encryption. The encrypted messages are like this, but it is bit more complicated than this. So now moving ahead, I would like to show you the code that I have written. So I did it in a Python. I wrote it in a Python code. So it is in a NumPy. So I just input happy life over here as question has given us to like happy life, and I just did minus 64 over here because ASIC key start from ASCII number starts from 64. So minus 64 if we do over here, then it would be 8. So like happy 8, H would be 8, A will be 1, P will be 16, T will be 16. So after doing this code, I went to next code, and next code was the matrix given in the question minus 4, 5, 1, minus 1. So I put the output over here. So you can see I run it and it's the output. So this minus 4, these are already in a 1 to 10 matrix or like that in a straight one line, but I need it in a matrix form. So to keep it in matrix form, I kept the code over here reshape into 2 into 2 comma 5. That means 2 into 5 matrix. So as you can see over here, 2 into 2 matrix, like over here it's an array, so it is in the 2 into 2 matrix. After that, I multiplied this matrix, this 2 into 5 and 2 into 2 matrix over here. You can see NP INP over here, A dot IMP mat. IMP mat is over here. Print IMP mat is this one, IMP mat, and the A means this one. So I have to multiply A dot IMP mat. So the message has been encoded. So the message is encoded. After multiplying, the message is encoded. So encoded message is equal to C, because in programming, if we keep just one digit, it will be easier for us. So the encoded message is C. So after that, I inversed A. You can see over here, A means this one. So after that, I inverse it over here. Inverse of A means inverse of A is equal to NP LINALZ dot INVA. So that means inverse of A. So after inverse of A, I multiply encoded message with inverse of A. After that, that means it is decoded. If we multiply, as I said before, in multiplying encoded code with inverse of A is the answer. So is the decode. So as you can see, I have decoded over here. So you can see this is this and this one is same, because it's like RHS is equals to LHS proof. Like I did that and again it came like this, up down. So after that, you can see over here, that you can see over here after that decode, like if I keep the output like HAPPY space LIFE, then it would be wrong. So I keep it in a one straight line because it would be easy for us to read what is the message. This time it is the short message, but when there is like more sentence, then it would be hard for us. So in a straight line, and I kept over there, like I flattened the code into 1 10 matrix kind of, and after that print message. And if we do that, then I kept character int plus 64. then it is HAPPYLIFE space LIFE. So this is the code that I did it in paper and in programming too. Thank you.